Right, well, let's get started then. Thank you, everyone, for coming to the Future Data Driven Summit 2021. I'm glad that we have some events like this taking place, and hopefully I'll get to see some of you at some point in the future in person and live. And so please, when we do get back to live events and it's safe, please feel free to come up and say hi. So today my talk is on kind of a vision of the future of database development. This isn't well, I mean, it's a little bit of reality and a little bit of where I think things will go. This comes about from a number of years of talking to people, doing some research and looking at trends and then some experimentation as well. So this is kind of a visionary idea, I think, but it is one where I think we'll get there in the next 5 or 10 years. So with that, let's get started and make sure I have the right thing going here. So the agenda is I want to talk a little bit about getting started with software development. And this is certainly from the perspective of databases because this is Future Data Driven Summit. But really what I want to do is get into how we could make this easier and better and smoother for people that have to do this work. I'll talk a little bit about containers just for level setting so that we're all sure what we're talking about. And then we'll look about some of the things that we do in modern software development that I think is where we'll go in the future. So my name is Steve Jones. I have been doing this stuff a very, very long time. I first connected to a SQL Server to do, remote client server development 30 years ago in 1991. And then since then, I've continued to do a variety of different roles. I've been a DBA and working in the infrastructure and operations area. I've been a developer, both for application software and database software. I've managed both groups throughout my career. And I've done that in a variety of different companies and industries, big and small, and in different areas across 30 years. Right now, I'm a DevOps advocate for Redgate Software, which really means I do things like this. I go out and speak to the public. I do a lot of pre and post sales for Redgate as well. And, we build tools for database development and monitoring and that kind of stuff, but I work with them there. And then I continue to do a lot of community work, and Redgate funds that, or they allow me to do that. I founded SQL Server Central years ago with a few partners, and I still run it today. Redgate pays for it, and they pay my salary, and they devote a fair amount of time to that. And they continue to support the community in a lot of ways, which I really appreciate, because helping people get better at their jobs and learn more is something that's been an important part of my life for the last 20 years. Microsoft has also honored me with the Data Platform MVP for the last 14 years, and I'm glad that they recognize my work as being useful to their customers as well. So, I'm old and I've done this a long time. So that's kind of where I come from when I'm trying to give you this future thing, is that I've seen good and bad software development, and I've seen this happen in different ways. My contact information is there at the bottom, and I'll have it at the end as well. And please feel free to get a hold of me if you have questions or comments, and please feel free to ask questions here today. So let's get started. Now, software development from the application side is fairly easy in the modern world, and I'm always amazed at this. You can git clone some code, and for the most part, you can just start working with the code. IDEs today in the modern world tend to manage dependencies with different package managers, but it's still not perfect, or it's still not super easy all the time, but it could be easier. And I want to give you a little example here. I've got this video that I put together, and this was live at the time I did it. And what happened is I went out and did a search in Google for just a sample.NET project that used a database. Really, that was the extent of what I did. I found this eShop web project, and I ran this git clone command, which copies the code down to my database. Now, that, for those of you that may be as old as I am, that may have worked with people online before, worked with SoundForge or other types of project sites, git clone is phenomenally easy compared to how I used to get code to run. Even in enterprises, sometimes getting code from somebody else was difficult. And really, anything beyond a simple, exe didn't work well. Now here I'm connecting to the web server, and this is running. And those commands that I ran are all I did to make this run on my system. I didn't install any software, didn't have to go update .NET, didn't have to do anything. I ran this git clone command, then I changed directory in there, And then I ran two Docker Compose commands. I ran a Docker Compose build and a Docker Compose up, and that was it. And I had a working application. And to me, that was pretty phenomenal. I think I first did this late in 2019 when we were putting this talk together. And I was kind of amazed at how easy it was for me to get a .NET application working. And as a matter of fact, let's open up. I'm going to open up Visual Studio Code here, and I'm going to pop open that folder. And this was really all that happened, is that you'll notice this, when I pop open Visual Studio Code, it has a number of projects inside of this folder. It actually asks me down here, do I want to install some extension to make this easier? And a lot of that has to do with the fact that in this project, there are a number of files that are set up to make this easy. You know, there's a Docker Compose file, there's some of these .dockerignore and .gitignore, but the solution here just made it open and made it simple for me to do it. Now I could change things in the code, right? All the code is here, right? I've got my controllers. If I want to look at that, I've got all the stuff that I need to do to play with this code and work it. But just running it in that Docker Compose was amazing. And really, the part that I thought was just kind of, you know, incredible with that whole thing was that, you know, I could come up here and go to this Docker Compose file and say, build it. And it says, well, there's actually a Docker file that we're going to use to build this. And that is in this web here. And this is a simple piece of code that actually pulls a container from somewhere. It does a few different things here where I'm copying some files, running commands, and then that's it. I'm setting it up. Essentially, I'm saying run .NET at this point, and then I have an application running. And that is with a database as well that's included in there. And to me, that's a pretty phenomenal experience to have that happen that simple for a fairly complex piece of software. It's got to run an internal web server, a database server, all that stuff to actually sit here and work. And I think this is one of those reasons over the last 5 or so years that most developers I've run into are very excited about containers. Not as many database people, but certainly developers that work with application software of all kinds, Java, Python, .NET, it doesn't matter. They're all excited about containers. And I've ran into containers, well, over a decade ago, and it's been amazing for me to watch the excitement grow in the last, 10 years from very little to, wow, we should all do this. And really, it's because it makes it so easy to run an application or any software, essentially. And the important thing here is that if I can get the container running on my desktop, I can put that container on a server and it will run the exact same way. Or I can put it up in Azure, or AWS, or GCP, or really anywhere that containers are supported, and it runs the same way. I don't have to install some software. I don't have to configure things. I don't have to do anything crazy. It just works. That's the idea. And now I want to see that happen in databases. And so here's kind of the vision of the future. Let's assume that Redgate's going to let me do a new job. They're going to let me do some web development. Now I know about databases, right? I'm experienced, but and I know how to do some web development, but I don't want to worry about the database side of things, right? If I'm going to move to a new team and get started, I want this to work. Let's assume I don't have SQL installed. I do, in fact, have SQL installed, as you may have guessed, but I'm not going to touch my local instance in any way here to actually start doing full stack development. All I've done really is clone the source code. Okay, that's all I've done. As a matter of fact, if I pop over here, here is my project where I've just got the source code cloned, and then I'm running it. Now, the README for this project, I guess, says this is a complex application. So it's got a React front end and a .NET Core API, which all kind of run together. Those aren't separate machines. It just, that's the structure of what we're doing, so that we've got a front end and a middle tier kind of thing. But then I've got two data services. I've got a SQL server and a Postgres server, and I'm using those for different purposes. A lot of you might think, oh, this isn't something I would do, but I have been surprised in the last 3 or 4 years how many customers I've talked to that have multiple data stores working with an application. And as we see more and more, people are moving stuff to the cloud. And while some may lift and shift things, some may move part of their system to the cloud to a different data store. Matter of fact, just before this, Mr. Paul and I were talking about the past summit, and he's going to talk about moving some, on-premise data into the cloud, kind of going from, I think, SQL to NoSQL. And that's a common pattern I see. And I'm surprised at how often I find customers that run Redis or Elasticsearch or even Postgres alongside SQL Server. So this is my architecture. I know I've got to do this. I don't have Postgres installed on this machine, actually, but I need this to work. The other thing I do get is I get a login to a database as a service. And I'll talk a little bit more about what this means. But for now, you just have to know that it's a spawn thing. They said there's a login, and so you should do that. Here's a video I actually made early on when we were putting this demo together. And I'm showing this from my laptop that I don't have SQL running, but I just run this yarn command and make this work. This used to work pretty well. We've actually made it simpler now. And so all I just need to do is I've cloned the source code, I authenticated to the spawn service, and then I just did this run debug, right, which is a common thing, F5 in Visual Studio or Visual Studio Code, and it starts to run things and get my application going. Now, as we can see here, it does say, are there containers around? So part of what I'm trying to predict or to advocate in the future is that containers do matter here and they're useful. But I didn't have to do any real setup here. I didn't download anything. I just started this application, right? I cloned the source code, I authenticated, and then it started this PS1 command. What this is actually doing, there's a command line utility here that came as part of the authentication. I would have run this auth command here, but there are a number of just commands that are available for me to run. And so for here, what I'm going to do is say get data container. And what we're going to see is that it's actually got a few data containers that are out there. And so if I zoom in here a little bit, it's created me 2 containers with these names. You'll notice I have a Postgres container and I have a SQL Server container as well. So without me having to do anything to my system, I've kind of connected or built these data stores that are useful for me. Let's see where my application is. I think it's doing some migrations here, which is making sure that my database is up to date with my code. You'll see here it says it validated 3 migrations. If I were to go in here and look at my database code, there's actually 3 migrations here that are running. And these are just SQL scripts that are out there. It didn't have to run those because they've already been applied to this version of the container. But if I had more there, they would have run. I think this thing is about up and running. Let's refresh this and see if this is actually working. I think it is. So let's connect to the application. Okay, it's working. You can see I've got some stuff here. And if I say feature data driven here, I can add another task. So it appears that my application is working. Well, where is this stuff? This could just be in, in memory. It could be in a data structure of some sort. Is it actually out there? Well, it is out there, and that's what I want to show you. So let's start with the SQL side here. This is the name of my container, and I'm going to get just some connection settings here so that I could use them. Right? So I get a connection string of some sort here. I'm going to grab this thing here, if I can get my mouse to work correctly. I'm going to go over to Azure Data Studio. I could use any sort of tool I wanted, but I'm going to come here and I'm going to say I'm going to connect to the SQL Server here. I know it's SA, bad practice, but there are things you have to do with SA. Here is the word, and I need to trust the server certificate because there is some authentication there, and we'll connect to this thing. Hopefully. We connected, I see a thing, and let's run this. So there are some accounts, just so we know that this in fact is working. I'm going to log out. I'm going to log in as me. Now this sample app actually doesn't authenticate that kind of stuff. It just takes what you put in there. So if I run this again, you'll see that we've added my account in there as a new user. Okay? So it is actually live there. I'm going to log back out and go to my demo account because I've got this future data driven in there. Let's see if that's actually out there. So I'll go to the other container, which was the to-do one, if I can spell correctly. Now this one is Postgres. So I need to connect to it a little bit differently. Fortunately, I still can use Azure Data Studio. And I'm going to connect in here and say this is a Postgres server. And I need the username here. You'll notice it is a different password. And it's a different port, which I need. Where's the port? There it is. Now this, it might seem like there's 32718. Let me just put that in there. 32718. Might seem like this is a lot, but having a command line interface means that I can glue things together and have them working in different ways. I think this might have died. It did die. Let's restart Azure Data Studio then. The one thing I will say is the Azure Data Studio Postgres extension is not the most stable thing in the world. Let's grab that stuff again. So instances, I could type some of this, but I tend to mistype stuff more often than I do. Just so we'll grab this, put it in there. We'll grab a password and 32718. Let's do 32718 and connect. And that should work. And I need to go to the other database. And in fact, if I run the demo one, I should see that future data-driven item in there. And come on. It is there. It's marked as true, which is what I actually did here. I marked it as true. If I were to mark it as false, it would be marked as false here. So I'm actually connecting to a database and making changes from my application, which is kind of a neat thing that I could just get this up and running. I'm going to log out of this quick. I'm actually going to stop my application now. And I had this thing running and working. And as you can see, you know, I didn't do a lot, right? There was a bunch of stuff that ran in here. But for me, I really just did run start debugging, right? Or F5. Normally I would click F5, but you can't see me clicking it. So I like to just use the menu. And I had a .NET application running in there with database backends, and not one, but two database backends. I had this account database and I had this to-do database, right? This one is Postgres and this one is SQL Server, just up and running without me having to install software on my machine, which I think is pretty phenomenal right there. This is all you would really need to do to make this work. Not necessarily have to have the spawn authorization, but you'd run git clone, you'd run spawnctl to auth, and then you'd open it in Visual Studio Code and press F5, and that's it to run an application. Now, I don't know about any of you watching this, but I've never had an experience set up as a developer that easy. And while it may seem that this was a bunch of stuff to set up, this is all I had to do. You know, originally there was, when we first set this up, I had to download Yarn and a couple things that I had to install on my machine. But when they updated this demo, and I got actually a new machine, this is a new desktop. Earlier this year, they said, hey, just update your repo, which I had already cloned it, so I just had to do a git pull. Auth to the spawn, which they had smoothed out as well, because I used to have to actually cut and paste the token back in. And then just start this project in F5 and see what happens. And it worked. And that was actually amazing. And so our goal, I think in the future, is that we don't want developers, whether they're full stack application developers or database developers, they shouldn't need to install database server. They shouldn't need to futz with, do I have a domain account for the services and where am I storing stuff and all this other stuff. It should just work. We want our connection strings to be simple and easy. Now I'm putting those in and cut and pasting them to my tool, but for the application piece, they're just there. And I'll show you how that works here in a bit. And more importantly, I want my database to kind of start up and be there. If the code in my repository has changed, if it's superseded where my current development database is, apply those changes. Just bring the database up to date, because that's what happens when I do a git pull and pull new code down from my application. And more importantly, make sure I have some data in there so I can actually use the database when I get started. And I don't have to create my own seed data as a developer. And then lastly, I just want to use existing tools that I use for development, which for me is Management Studio, Azure Data Studio. Potentially there's other tools as well, but I want it to just work with what I know. So that's the vision. That's where we are. Now I want to kind of jump in, kind of level set of how does some of this work in the back end, or how will I think it work in the future? And we'll start with containers. Before I go further, any questions, anything I need to look at?
There is a question, Steve.
Sure.
Do you want to read, or I should read loud?
I don't know how to see it right now when I'm presenting.
Okay, sure. Sure. Let me do that. Samir asked, do you think we are at the right place when it comes to the stage or capabilities of technology today, especially the human-machine interface? Will we see more changes in this domain? Maybe more talking to machines interface.
So if I read that right, are we at the right place for this type of thing happening where we have more things working together? I do think we are there, perhaps a little bit early in that cycle. And so let me keep going. And if that question is still relevant, please post it back again, because I do think that we are at that point. There are some people that are ready to do it, some people that are not ready to do it, but the technology is kind of there now. And I don't know that anything will win yet, but it's there. So let me keep going, and let's see if I can answer that question. So let me start with what containers are. To do that, I want to back up slightly and try to just do a comparison with virtual machines. So for most of us, we have hardware of some sort that we work on, and then we have an operating system. It could be Windows, Linux, Mac OS, regardless. We set this up, and we really have a computer. Now, at some point in the 90s, we really wanted to emulate multiple systems for developers, from the developer side and from the server side. And so we started to look at virtual machines, which require us to put a hypervisor on top of our operating system. Now, this actually existed a long time ago with OS 360 on mainframes and VMS and various other mini computer systems. But in the kind of the PC area or the commodity hardware era, we started to go with hypervisors, which would emulate our hardware again. And on that hardware, we would install an operating system again. Right now, there's AMIs, there's various ways to do this, but essentially we have hardware emulating hardware under a hypervisor, and then another copy of an operating system with its own kernel, its own services and processes and all that. And then we install application software, right? Could be, a web application, could be SQL Server, could be, some C++ thing, doesn't matter. And we could do this multiple times. And so as developers, we use this because maybe I need to run Windows 10 and Windows 7 and Windows 2000 or XP, or maybe I want to try something under Linux and Windows and Mac OS, right? I have the ability to kind of make the operating systems at the top different from the ones at the bottom, or they could be the same. Maybe I want multiple Windows 10 configurations. It doesn't matter. I can do this, but there's a limit to how this works. In a container world, we have something similar. But instead of a hypervisor, which is a fairly heavyweight piece of software, we have a very thin runtime. Now, I've used the Docker runtime here because it's the most common, but this is really just an API layer. It's incredibly thin what this actually does. And then what I have is this thing called an image, and an instance of that image is a container. And just like with VMs, I can add multiple containers to do the things I want. But because both the container and the runtime are so thin, the density of what I can do is much, much higher. And this is really why containers have been growing and in use heavily for some companies, because there's a density ability here. Now, the underlying hardware is still a certain number of resources, right? There's no magic here, right? If I've got 4 cores running on a machine and I've got 16 gig of memory, there's no magical way to use more than 4 cores and 16 gig of memory. But the overhead of emulating these different systems is much lower in the container world. These really started in Linux, and they started, I I want to say 2008. I can't remember. I ran into them in 2009 or 10. I think it was 9, when they were the LXC project. And what this really was is a way to provide an application, a full-fledged Linux environment, without making a VM, without having to reinstall a operating system. Okay? And that was really what they were. These do use the host kernel as opposed to installing a separate copy of a new kernel. They're using the host kernel, and what they really are is an application environment. So they're allowing whatever's running in the container, whatever application is there, to think it's the only thing on the machine. It's the only piece of software running right there. And we do this by virtualizing the OS. So essentially, we use a namespace so that every container that runs thinks it has a process ID one in Linux, or a LSAS service in Windows, or whatever it's doing. But it's providing name collision protection with a namespace. And then control groups are a way of managing resources so that we have a way to ensure that one container doesn't run away on the machine, right? Just like the hypervisor allows me to prevent one virtual machine from using all the memory or all the CPU. That's essentially what we're doing. Now, Docker used the capabilities that are in the OS, and they really built an API engine there. And for whatever reason, it became very, very popular. There are plenty of other container implementations. And like I said, they're really just calling APIs in the OS to set up a new namespace and a control group for managing a container. That's really all that's happening. An image that I had on a diagram is a template of the file system, because I need RAM and CPU, but I need a file system to actually run things, right? I have to have programs to load and write things down and all that. And so I showed you that Docker file in that sample app. Really what this image is that every time you've made a change to the file system, it creates a layer, and then the file system unifies those to give you a consistent view. And that's all the image is that it's a view of the file system at a point in time that you've put together. Now, this entire file system is read-only in the image, but you use that to then create a container. And this gives us a base from which we start. And this is why this is very repeatable and reliable, is because every time I start a container, it looks like this read-only version of the file system. So whatever I've installed, whatever versions of DLLs or C++ or Python or whatever things are there are there every time I start a container. Now the container is an instance, and all of the containers built from that image share that image. So they actually use that read-only version of the file system. But each time I start a container, I get a little writable layer, a really thin layer. And so any changes I need to make, right, if I write back to the database or I write to a page file or change something, that has to have a place to work. I mean, that's what computers require. But these exist in these little writable layer. And the unified file system ensures that for the purposes of the container, whatever application is running thinks it's a normal file system. It doesn't realize there's a read layer and a read-only layer. Or sorry, a read-write and a read-only layer. Instead, it just sees a file system. Okay? Now, as long as the container is alive, whether it's paused or stopped or anything, the writable layer is there. If I delete the container and restart it, really restart a new container, then all that goes away and it looks like a brand new container. Okay? There are lots of other capabilities like volume mounting and things like that, but essentially what we're trying to do here is we're creating a very thin container layer that looks back at a read-only version of whatever process I'm running, and then it runs normally. Right? And that's where we get some of the scalabilities, because we're all looking at this read-only image. I don't have to have 10 copies of an operating system and a file system. I just have one, and then I have a really thin layer to do some things. Good and bad, there's positive and negative, but that's essentially what we're looking at here. And so now that I've kind of talked about what containers are, how does this help me in development? What does this really mean for me, and why is it valuable? The big thing from the development standpoint is something that plagued me for most of my career, whether I was a developer or an operations person, is that things didn't always work the same on different machines, right? Developers constantly said, and I've said it works on my machine, and we put it on a server or on a client, it doesn't work. Well, containers solve some of that because everything is inside the container. If I run a process, right? If I run SQL Server, or I run, a utility, or I run Flyway, or anything I'm running, it runs inside the container. All the dependencies are there. Everything that it needs is inside there, and it just works. And it works the same everywhere, which is phenomenal. That is the true power of containers, is that I can move them around and they work. I don't need to tell somebody they need to go install the software or find this configuration item and change it. All that stuff is gone. And it removes some of the need for infrastructure, mostly in the provisioning, configuration, setup. Certainly, you still need resources, right? I still need CPU, RAM, and memory, but it removes a lot of the other things. And maybe more importantly, is that it keeps versions stable inside the container. Okay? That is critical. So I don't have to worry about, are we at the same CU level, or are we at the same DLL for some C++ thing, or any of the things that we've hassled with in SQL Server or in other applications. None of that's there. Now, for databases, when we talk about putting databases in a container, it works well for small data sets, not so good for large data sets, which is good and bad, and it's something to talk about. But let's assume for now, as I've showed in the demo, small data sets are how we're going to do database development. Okay, this isn't for production, not QA testing, others, but for production, this gives me something I can do. So let me move on and show you a couple things with development that I think help reinforce this as a vision. First thing is branching. So if you're a database person, you might not have dealt with branching a lot. If you're a software person, especially in the last 5 years, you absolutely have been branching. Branches allow me to make a copy of code without disturbing other people. Right? Some of you may work on shared databases, and you may run into this problem where you update a store procedure and then somebody else updates store procedure, and only one of your changes lives there, right? Whoever's last is there, because what you're editing in Management Studio or in Azure Data Studio is in memory. Until you compile it on the server, that's where it is. And if somebody else has their own editor open and they make change, it's their change. Branches in the application software world make it easy for me to experiment and commit and do things separately without disturbing anybody else or them disturbing me. And I can discard changes, I can recreate them, I can do whatever I want to do, which is phenomenal. And then when I found something that works, I can merge those changes into everybody else and send them around. We don't have a good way to do this in databases. I spent a lot of my career the last 10 or 12 years with Redgate trying to solve these kinds of problems and make it easier for people to do or perform database development smoothly in a team. And this is a hard problem. And really, containers make this work better. Okay? The important thing is containers are immutable here. So I can restart a container and return to a known state, or I can branch with a new container and make changes. And so then if I need to, then I can commit that to a version control system. And that's a pretty unique system. Most of the time I talk with customers, a bunch of developers are making changes in the same database. Most times it works pretty well. Sometimes it's very painful because code is confusing and it's getting overwritten. So let me show you something here, or show you at least a vision of how easy this can be. I've got this code. We set it up. We ran. We're in the main branch. Let's create a new branch. And I'm going to say this is the feature data driven branch. It's down here. If you haven't used Visual Studio Code, it's there. It's my branch right now. Nobody else can see it. I could send it around, but for now, it's just my branch. So let's create it and let's go. I'm going to do some work here. Actually, let's stop real quick. Let's let that stop. Hopefully it'll stop. Let's delete this process. Let's delete a few of these. Go away. All right. So I think this is fine. Let me just see if I've done anything weird here. Yeah, let's delete that. So the call went out there. I want to do something before I do this. I want to show something there. So we'll delete that thing. There you go. I made a mistake right away live, and we'll fix it. So I've got this branch. One of the things I'm going to do is I'm actually going to take this code. Let me move some of this out of your way here. And I'm going to just save a copy of this file. Now, normally I would do, if I was actually doing this, right, I would do it in Azure Data Studio. Or Management Studio or somewhere else, and I would create some table. And so let's just for the sake of making this easy, I'm just going to save this. I'm not connected anywhere, right? So all I've done is add this new piece of code in here. It's listed here as something that's uncommitted. Let's see if this works, right? Please don't commit code that you haven't run to certainly not your shared version control system. But in this case, I'm just going to do this for the sake of this demo. And so what this is doing is it's looking to see, do these containers exist, right? It's going to say none are found, so I'm creating new containers, which makes sense, right? That I need to create new containers here because I want a branch. I want something different. And so what it's actually going to do now is create these new containers that have a similar name. So as we can see here, it actually has completed the Postgres one, and it's doing the SQL Server one. You'll notice these are, let's zoom in here. This is very much the same here. This is my branch that I was on, the main branch. Here's my new branch. And so that's a good way to just kind of keep track of this. And this is something we came up with, well, not me, but the guys that put this demo together came up with this. And what they really did, let me pop this open and look at it, is they do some work at the first thing. So there's some configuration that says, here's what we're actually using as developers. We're using these images to do development in this project, which is a very simple configuration thing. Then what it's going to do is get to get branch name, and then it's going to, in fact, try to set things up, and it's going to return the image with the branch as the name to use. Okay, and then it'll do some error checking. There's various things that are in there to say does stuff exist. It'll actually rewrite the connection settings here for the branch, and then it'll get going. It'll return some of this stuff. Hopefully, I didn't do that. If I were to go here, this API spawn demo, yada, yada, yada thing, which is here. What I would actually see is that the connection strings are here. Right? There's the port and there's the other thing. And those will match what I would do if I were to come in here and say, get me the, let's say the FTD one. I think that's what's there, because we're going to need to connect to it anyways. These connection string settings, right? So 30318, I think that's what's in here now, 30318. It's actually been rewritten. And in fact, if I were looking at the output for the terminal, that's actually what happened, right? Is that it says it's rewriting it and sending it on, okay? And here, notice this time, there are 4 migrations, and we're actually migrating the schema with that new file that I did. So I didn't typo anything when I created that file from scratch. I created a new thing. And so if I actually go and connect to this system, and I'm going to come here and grab this stuff. So 30318, and let's grab this password here. Nope, this is the password. It's a different password than before, if you remember. So let's come over here and let's connect. And this is here, and we're going to say 30318, which I think was correct. And let's grab this because I don't feel like typing. Paste that in there. And that's completely incorrect. And then it's instances. Right, and so this should connect me in there. Here was my original one. So if I looked here, we have that future data driven item in there that we added. Here, I'm going to connect into the other one and run this. And if I was in the right database, it would run. But you'll see here that I don't have that future data driven one. Right? I've got it here and not here. Here's my branch that I've connected to. Now, the tough part is keeping track of this in other tools, but in my main tool or in my main environment, this is there. And if I come back to my application and we log in, what we'll see is that I have those original tasks, and we know that this is the right place because I'll mark all those as false and run this again, and they should all be false now. This is feature data driven live. And we should see that here. This container is still around, right? So if I was making changes and experimenting and I'm wondering what data I changed, I could certainly see the old and new data there. But in both cases, I could restart from a point in time and be right there, which is kind of phenomenal, right? If I decided that whatever I'm doing in this branch is no good, I can just delete this branch. I can delete those containers, create a new branch, and I would get a new set of containers up and running again, right? And certainly I can do restore a database. I can do database snapshots, but that's pretty phenomenal. And more importantly, for the non-data person, the full stack person, that's just handled by me changing branches here, not from me doing any sort of work on the database server, or in this case, servers. Okay. Now, let me keep going. I want to show you something else before I go further. So when we do development, I'm sure those of you who do database development or application software, we change data. And if you're like me, we make mistakes. Now, I can reset app code easily, right? I can stop the application and restart it and it just works. For the database, it's harder if I've changed things. I have to write code to undo something, or I have to have made a snapshot, or I have to do another restore. There's lots of solutions to this, but they all contain a ton of friction. So how could I make this simpler or easier? Yep, I just want to make sure that was the last. Let me come here and show you something. So this FTDD Live, right, this is our current system. And if I change this and I look at it, I set it to true. So it's true now. That makes sense. What if I want to delete this item? Well, it's deleted. Okay, is it gone here? Oh, that's bad, right? I lost all my data in this table. Matter of fact, if I were to go, there's probably some data in there, but there's none for this user. As a matter of fact, if I even didn't care about the project, it's null. So that's bad. What happened? If I refresh my app, it's gone. Everything is gone for this user. There's a bug in my code somewhere. Now I know that, but before I go further, what I really want to do is be able to get back to where I was. Well, fortunately, the database as a service gives me a capability to reset the container without changing all this stuff. It resets the container. Now, I actually have capabilities. I could have checkpointed the container at that point in time and reset back to a checkpoint, right, if I'm doing a bunch of development. But if I'm, in this case, I was at the base container, I can just reset it. And it's running a little bit slow, I think, because it's late at night in the UK time, and we're in the London AWS data center, and it's going to bed. It's slower than I would have liked. Hopefully this will reset in a second, and it should bring me back to that point in time when I first started up with this new branch. When I first created these containers here, it should get me back to that point in time. The frustrations of live demos. So if there are any questions, I'll ask for some in just a second, so just get those ready. We've reset, so that's good to see. If I were to come back here and reset my app, I should see this there. It has to do a reconnection. I don't know what there's in there, but I should also see here something. If it hasn't lost my connection. Let's disconnect and reconnect here. This is and the username is here. Where is here? That's the one thing I don't love, is that this using Azure Data Studio for demo, as much as I like the tool, it is a little bit flaky in this Postgres extension. So there is stuff there that we had deleted. In fact, my 4 items are there. And if this were to come back, let's come back in. I don't know where all the retry logic is in this thing. They're there. Now my FTD Live, I'm going to make this live too, isn't there, but I'm now back to the point where I can try to fix this thing. And as a matter of fact, I don't want to dig through this too much, but in terms of fixing code for something that happened, right? There is an easy way to do it. I can search for it. Me as a new web developer, I know it's not a project thing. It seems to just be a thing. And in fact, when I come here, what I find is that we're not actually using the proper delete clause, which I'm a data guy. I know this is right. So I'll do that. Now I've got 2 changes in my thing. Let's see if that fixed it. So I can restart my app. It'll do that. I'm going to say commit. I've got tremendous confidence in my ability to do this. So I'm going to commit that change in there. And then once this restarts, what I should do, it'll reuse these containers. They're still there. And when I'm looking here, if I come back and show you what's happening here, the terminal is that it's reusing the containers, right? It updated the connection string again. It's looking at the account database. Well, that's at the current version because I didn't have any code there. The to-do database should be at the current version as well because the last time we started, those 4 migrations were validated and the 1 was apply. Oh, actually, because I did the reset, it's actually got to apply this as well. And so now it's continuing on. And as a matter of fact, I should have shown you that this table actually exists. And it does, right? There's that table that exists there. And now if I get my application running, which I think it is running, and let's log out. Let's come in again and see this. My FDD Live 2 is there. If I delete it, it's gone. But if I refresh this time, I have all my stuff there. And if I come back and I said, if I'm looking at this stuff, is it there? It is all still there. So I fixed my bug. Right? I've gotten this thing working. Now, let's stop that. Certainly at this point, right, if I said this was right, I would create a pull request to merge these changes in. You'll notice if I come back here to my database side, right, I've got these 4 things here. If I were to go back and look at the main branch, that 4th one isn't there, right? And certainly that to-do fix isn't there. So this is the type of thing application software developers do. But as a database developer, I'd like to do this as well. If I add a new table, I want to pull request it. I want other developers to look at it. I want them to be aware that it's out there. I want it to be tested and looked at. And then I want to merge it in so that the next time somebody runs a project, they would do a git pull. They would see the new version 4 of the database and they would run that code. And that would make it happen. For this part of it, for the database developer experience, the idea of having database as a service really simplifies and smooths things for everybody. For IT people that have to manage resources, for the developer, whether their database or application, it just smooths things out. And it offers a lot of features and capabilities, which will be, I think, the future of database development. Right? Using containers gives us this known consistent point so that all of our developers always have the same data set, which means that we don't have people testing different things and maybe solving part of a problem domain and not the other part of it because we've got it there. And then because I've got a database as a service, I can integrate with my app easily. Right? And I have the ability to then do things like reset and branching and all the other stuff that I do. All right, let me move on to continuous integration. Actually, let's just hold questions at the end because I'm going to try to just get through this quickly and leave a little time. So for database people, I know a lot of them don't do continuous integration, but application people do. And typically what they're doing is verifying and validating the code on a different machine. So whatever worked on your instance, your database, your desktop, laptop has to work somewhere else. And so we want a simple process to do that, which means that we're grabbing code and then we're testing it somewhere else. When I do this with containers, the nice thing is I start from a known state and then I do the upgrade and run things. And more importantly, I can run things in parallel, which is difficult to do. If you think about all the things you might test on your database, what if you get 6 things done and then the 7th one uses some of the tables from the first 6 things? Is the data reset? Is it the same? It can be a real challenge to do good testing on database code if I don't have the ability to ensure that the systems are there. Now, there are frameworks like T-SQL-T that help us out, but it is a challenge to actually get really good testing if I don't have a way to start in a known state. So containers really make this easy. So I'm not going to demo this per se, but I do want to show this project. So we put this together, and we actually have an Azure DevOps running CI. And when it connects in, we'll go to the pipelines, and there's a build and test pipeline. So this is continuous integration. And in terms of what's happening here, there's a build stage, which is really putting together the current images that we need. Okay, so it's building a front end and back end image, or building it. And then in the test stage, we're upgrading the images, right, with the migration. In this case, what we're actually doing is doing that stuff we did before, right? We're migrating the account database, migrating the to-do database. And then what we're doing is we're running tests, right? Well, it's adding data here in this stage, but then it's running tests. And if I zoom here, right, like a lot of this stuff is the same where it's getting set to go, but here it's running unit tests. And all of these here do the same thing. They're running sequentially, but they're running different sets of tests. And because they can restart images, they all can run from a known starting point. We can validate that we're actually testing a specific code we want to test. And we're not accidentally making a change in one test that invalidates another test, or then ensures that we can't run another test. And maybe more importantly, I could run, this thing and this thing and this thing in parallel. So I could have it running much, much faster, right? That's all about configuring how I do the continuous integration, but it can run fast. Okay. All right. I've given you a vision, tried to show you where I think we're going to get to at some point. Here's where that question comes into play about where are we in this point in technology and what's happening. There are database as a service possibilities out there. The Spawn thing is from Redgate and it's in beta. There are similar things available from some other companies as well. And really, I think this is the area we're going to go to. But the challenge from everybody trying to do this is really about the data piece. And the first thing is subsetting, because while a terabyte database is possible, right? In matter of fact, we have the Stack Overflow public database in Spawn. So if you need I don't know if it's 300 or 500 gigabyte database, we have it. But as a developer, that's a very cumbersome database for me to work with, because queries I run across that database take a long time. And if I make a mistake, I'm updating tons of data. It's not that I don't need that data to test with at some point, but for most of my development, I need a subset. I need 10% or 5% or 2% of that data. And so subsetting is really a challenge there. I think this is hugely important. And so if you agree, really what I need you to do is like send an email to sales@redgate.com and say, we need subsetting, and send it to other vendors as well, because this is an area that isn't complex, but it is complicated to solve. The other thing is that as we subset, we get the size down, we need appropriate test data. So we need a scale, we need a spread, a skew. It has to match my live data in some way that allows me to test the different types of problems or the different cases of the problem appropriately, right? All the weird things that my users enter into, names and addresses and dates and stuff. I need to be able to test a variety of those things. And so getting that right in subsetting is very difficult. And this doesn't even come into play the privacy issue of trying to not put production data in test systems, but these are all issues that are difficult to solve for any individual, and even for vendors. They can be challenging in a general sense. For a specific application, these actually aren't very hard at all, but in the general sense, they are. And then the last thing is, as we start to make more containers for developers, more containers for CI, for parts of QA, right? Not the performance full-size test, but parts of QA. We need to orchestrate all these containers, and that's a challenge for a lot of organizations. We actually are running the Spawn thing in Kubernetes, and it is it's non-trivial. That's why I think at some point none of us will want to run Kubernetes. We'll just want to run in AKS, and we'll want somebody like Redgate or Amazon or somebody to handle the difficulties of Kubernetes. As a matter of fact, it was acting up earlier today, which was maddening to me. But these are the things that prevent wide-scale adoption. But all these things are possible right now, so you can do this stuff inside of an organization. And so the technology is available. Let me summarize, and then we'll get back to questions. So I think the future is going to be database as a service, because there's no need for me to provision a SQL Server on my machine any longer. There should be a configuration setting that just makes a container pop up. For now, as I built containers with things like Pubs and Northwind because they're small, or even with Stack Overflow, it's phenomenal. It makes development much easier. Redgate actually has a non-container way of doing this with their SQL Clone product, and there's other companies that do that as well. It's not as easy as containers, and so really pushing Redgate and other companies to use containers and make this simple. This solves a lot of the problems of modern software development that we want to handle, like branching to have different copies of things, resetting when we have problems or we break data, or parallelizing the things that we want to do. Right? It's lightweight, it's easy, it's not magic. I can't run 20 SQL servers on my laptop and have them all perform well, but it is lighter weight and it does make things much easier to handle. And maybe more importantly, DBAs and security people and people that are concerned with infrastructure still have control because they can decide how the containers are built and how those images are made available to you, which means that they can ensure that we patch images and so we're up the latest CU, and that we don't do weird security things that we shouldn't be doing, or we don't change, threshold for query parallelism or other things. This really is, I think, the future that's going to make it much better. So with that, I'll end. Please rate this and other sessions and give us feedback and contact me if you need it. But are there questions now? I'm sure, or I would hope there are. See if any come in. Actually, I think I'm going to stop sharing because then I can see the chat and I can talk with people a little bit too. What do I see? Oh, I don't see any more questions, right?
Yeah, so I
can't hear you. Your mic. Oh, there you go.
Sorry. Okay, before I ask the question, actually, there is a other question from Samir. You want to read it loud or?
Sure. I can see it now. So do I think that data is the most important asset for organizations in the future? Absolutely. Because I think code software is, right? Like, as much as I sometimes complain about application developers, they are phenomenal in the things that they build. But data powers what they do. The data is absolutely critical. And we see that as people are trying to constantly run reports to make decisions, and we're starting to go into AI and all that other stuff. The data is critical. And I do think it's the most important asset because it will survive knowledge transfer, staff changes, everything else. The size of data in the future. So here's what I'd say. I worked with a company building some accounting software at one point, and as we were trying to spec out what they needed to do, what they really said is there's 17 things we do in accounting here that we have to solve, right? So there's 17 cases of things. Those are in our database millions of times, right? So that gives us a terabyte of data. But really, if you solve these 17 cases, then things will work. And so for the development side of things, we do need a small scale of data. We need a subset. We need that to be easily manageable. And that is a challenge because for all of us, we know, right? If I'm trying to change schemas and things, getting a consistent subset is hard. But when you do it, it's phenomenal. I have a customer that has a multi-terabyte live database across multiple languages in Europe. But they spent the time and they consistently work on it to have a 5 gigabyte data set that contains all the languages and cases they need to solve. And that's what they give the developers. And it's phenomenal how much agility that gives them. So that is where it's important. The scales in production, why do we care, right? Like that can grow as big as possible. The technology keeps growing to handle faster data sets and all this stuff. We need to be able to write code as developers in a smooth, easy way that mimics what's in production, but it isn't production, if that makes sense. All right. What's your question, Mr. Paul?
Yeah, my question is, you mentioned about the container size-wise, for the database. Like, is it, right. You mentioned if there is a small size, it works better, but not good for the big size. When you say small size, what size actually you mean in terms of example?
So small is relative, right? Like I think these days on modern laptops, low gigabytes is small, right? So I think my view would be how hard is it for me to transfer this around? So these days, not a lot of us are on LANs. You're at home, I'm at home. So what's the transfer size across a WAN if I have to update this thing regularly? I pulled down Ubuntu the other day because I was testing something, and that's 2 gigabytes, and that was slightly painful, right? So I don't have a great connection, right? I'm out here in the country. I think at 10 gigabytes is probably the most that's feasible for something like this to work at scale. But if I'm doing database as a service, that's not so bad because I don't have to pull a container to my machine, right? I'm not pulling those containers to my machine. I'm connecting. And the connection for a lot of us is a much lighter weight thing than pulling down lots of data. Still, when I'm building these containers and running them and stuff, if I've got, terabyte containers, it's cumbersome for development. I really think that it's got to be single gigabytes of data to be manageable for us as developers, even as ETL people. We're like, if you can load a gigabyte of data, that's, you can load a terabyte of data, right? It's just time then, right? Compute. But you don't want to have to go check a terabyte of data on a load over and over again. You want to say, give me hundreds of megabytes that I can test load. I can test all my logic and, Data Factory or SSIS or whatever I'm using and make sure it works. And then let's actually test it on a full size thing. And so those are the scales we have to think about, that we want things as developers that are agile for us, but still represent the problem.
I know we are kind of over time. I have a very quick question because this is something in my specific project I work with. So I always use the Visual Studio Database project for
Right.
kind of repository and things. But you shown about using the Git. Of course, when I do work with the ADF, I use the Git. But for the database project, I still using Visual Studio Database project. But do you see like using the Git as you show in the Visual Studio code that has?
So those things are not related, right? So the Visual Studio Database projects, right? The SSDT stuff is just files that they're putting together, right? You have a config file, right? And you run that through SQL package and all that stuff. That can be stored in Git. So I have plenty of customers using, SSDT and database projects with Git to store them, right? You might use Team Foundation version control, which is fine, but if you're using TFS these days, you can use Git with TFS. And I think Git is just far superior to TFVC. So those things can work together.